Good morning, good afternoon, and good evening. Welcome to another webinar from Continuant. Today we're going to be talking about geo-distributed clustering done right. We'll be deploying multiple active primary MySQL databases. My name is Matthew Lang, and I'm a Customer Success Director here at Continuant. I've got about 25 years experience working with databases, as well as doing sysadmin and DevOps. I've worked with MySQL, as well as some closed source databases. So on to the webinar. Uh, why do we want to do geo-distributed MySQL? And is it hard to do? Well, the geo-distributed database is going to give a better user experience to our end user. Well, why is that? Well, that's because the data and application servers are actually deployed closer to the user. Therefore, there's less network latency. That provides better response times and a better overall user experience. The thing is, there are very few databases out there that operate in a distributed manner. The reason why is it's actually pretty complicated. So we've got some challenges, and the one is replication. So all of our sites need to be replicated to each other. And then we have the challenges of replication lag when we're talking about geo-distributed databases. And then also we need to have data consistency across all of our sites. That's important because we want a consistent view of all of our data no matter where we are. To do this, we're going to have all sites active at all times. And this should be deployed in whatever cloud you choose, or on-prem, or a combination of both. So that would be hybrid and multi-cloud. So what are some of the use cases? This, of course, isn't a complete list, but it should give you an idea of who could benefit from this kind of deployment. So gaming, right? We want to minimize the number of hops for our gamers. Less hops means better ping times and an overall better player experience. And the medical field. So doctors are working with patients and they really don't have time to wait while their application is communicating with a distant database or a distant site. They need to devote their time to their patients. And IoT devices, right? Many devices connect from all over the world, and they need to be able to connect quickly or to be able to upload data quickly to a local site. Credit card processing, really, it's just an extension of IoT, right? Processing credit card transactions, say at a retail store, uh, it needs the best possible performance so customers aren't waiting. And then another benefit that we gain is business continuity. If we have multiple sites deployed, we can seamlessly fail over to a working site if one of our local sites goes down. And just as important, we can fail back when that local site comes back up. So let's take a closer look of what we're trying to solve. If we look at this diagram, we see a user who's in Hong Kong is working with a site that's located in New York. So every request that this user makes has to go pretty much halfway around the world. And then the response is coming from halfway around the world. And this happens for whether it's a read or a write. And a single, for instance, web page can open, say, 30, 100 reads and writes. So this would be a poor user experience. So what's one way that we can improve on this? Well, we can introduce a passive site that's closer to the user. So now when the user writes, it still goes halfway across the world to New York. But then in the background, there's some replication that happens. And that replication replicates to a passive site closer to the user. And now the user can read from that local site. So we've got a little bit improvement with this topology. And this is kind of what some of the managed database services like RDS and Aurora do. So again, uh, we're providing local reads to the application. So there's definitely some improvement with user experience. Unfortunately, writes are still done over the WAN. So whenever we have a write, we are going to experience potentially some poor performance. Also, those writes need to be replicated back over the WAN to the local database. The problem there is when the user writes, that information may not be available on the local database for him to read. So there's going to be some inconsistency in the data. Why? Because that replication traffic has to travel over the WAN, and there could be some lag due to the WAN performance. We also have some complication with failover and failback, but overall, this architecture can work well for workloads that have a high amount of reads and low amount of writes. But really, what we want to talk about here is geo-distributed multiple active MySQL databases. So let's get on to that. So to do this, what we first need to do is build a high performance local cluster. And here at Continuant, we use tungsten clustering for that. We use tungsten clustering to build the local cluster with HA and performance scaling. With tungsten clustering, you can use off-the-shelf MySQL, and you can use whatever flavor you want. MySQL, Percona server, MariaDB, and as well as any version that you'd like. And you can even mix versions. It installs seamlessly, so you don't have to migrate your data or alter your applications. And within a local cluster, we can perform automatic failover. So if something happens to the primary database server, we can easily fail over to a replica and promote it to primary. And we can add more database servers to improve read scaling. Tungsten clusters can be installed on-prem or in the cloud. We support cloud providers like AWS, Microsoft Azure, and Google Cloud. And also, I'd like to point you to the picture, the tungsten connector. That's the intelligent routing protocol that we use between the application servers and the database. And we're going to be looking at this more in a few minutes, but this is kind of the secret sauce that allows routing to the correct backend database server. So for instance, we can route reads to our replicas and writes to the primary. So if we look a little bit more in depth at a tungsten cluster, and this is a local cluster, we see the other components that are also installed. There's the tungsten manager and tungsten replicator. So the replicator, of course, takes care of all the replication within the cluster. We're also going to see how the tungsten replicator is used to extend the cluster to multiple sites. We also have the manager, and that's the orchestration piece. So as I mentioned before, the Tungsten cluster is a package where everything is included. You don't need any additional scripts or kind of DIY components or anything because the manager handles that with its orchestration. So let's see how we can leverage a Tungsten cluster and extend it to multiple data centers and clouds. If we're going to do this, let's get a list of some of the requirements that we're going to need. And this is the requirements to make sure that we're getting the result that we expect to, right? We want to be able to deploy multiple clusters and geo-distributed active-active. So the first thing we'd want to do is we would want to use off-the-shelf MySQL. And what that means is we don't want a special build. We don't want to modify our MySQL installation. We really just want to pick the flavor that we want: MySQL, MariaDB, Percona Server, and whatever version that we want. We are also going to need to have an active or a read-write database in all sites. So this is also one of the requirements that we saw that we'll need to give the best user performance. We want users to be able to write locally and read locally. And why? Again, we want to minimize the distance between the user and the application and database. lower latency, means better user experience. We are also going to need to have each site replicate to each other site and process replication events. So this makes all sites in sync. And also, one other interesting thing is just because we're replicating between sites, we don't want application performance to be impacted. Now, there are some replication technologies out there that when they're enabled, they actually cause the user application to suffer in performance, and especially over a WAN. So that's one thing we don't want to see. We don't want to see an impact to the user just because we're replicating to other sites and we're geo-deployed. And then finally, this needs to be an easy to use package, right? We don't want to have any DIY components. We don't want to have to build additional scripts or mix and match components. We need everything in one package. So that's the management aspect, the orchestration and the deployment, and the monitoring tools that the administrators need. So with tungsten clustering, this is really easy because we already have the tungsten cluster deployed locally and all the components are available. We just extend that to all the other sites and join each cluster with tungsten replication. This replication between sites is the same replication technology that's used within each local cluster. It's asynchronous, so what that means is replication happens in the background. We are not waiting for the database to acknowledge that we received a replication event and slowing down the user application like maybe some synchronous replication technologies would do. It's also managed as part of the manager process that we saw before. And we can deploy as many of these clusters as we want, say 3, 4, 5, all around the world, all replicating to each other, but users are using the site closest to them for the best performance. So if we look at tungsten clustering, active-active topology. So obviously we need a minimum of 2 clusters to have active-active. That's kind of a given. And like most clustering technologies, we prefer to have a minimum of 3 nodes per cluster. And there are several reasons for that. One is we like to have an odd number of cluster members, so we always have a quorum. And also, if we have a failover, we still want another backup database. So minimum 3 nodes. Now, all clusters are read and write. So each one has an active primary database server. We can deploy these clusters multi-region, so we can pick a cloud provider and deploy a cluster in various regions. Also, we can mix and match clouds. So we could have one cluster, say, in Amazon and another cluster in Google Cloud, and maybe a third cluster in Microsoft Azure. It's kind of mix and match, and you pick what works for you in whatever site you're deploying to. We have an integrated management system to manage the entire cluster mesh with one interface, whether it's GUI or CLI. And again, replication is managed as well by the same tools you use to manage the local clusters. And we have a dashboard view. So let's take a look at the dashboard view. And what makes this unique is our dashboard, it's a GUI interface, right, as you can see, but it actually allows you to manage the entire mesh of clusters with one simple pane. If you look at some of the cloud providers and some of the managed databases, one of the things that's really frustrating and makes it difficult is you manage by region. Your cluster might be deployed in several regions, but you only see one region at a time. And you have to click over to another region to look at that cluster. Well, here with the dashboard, we see the entire cluster deployment or clusters all in one pane. So again, Tungsten Dashboard is our web-based UI for monitoring and deploying and managing Tungsten clusters. In one single pane, we can review our entire cluster mesh. We can check out replication status, the number of connections to the cluster, the database states. There's a ton of information that could be put on or is available for you in the Tungsten dashboard. We also have command line tools that really perform the same functions. You can get an entire cluster view with our command line tools, and obviously you can write scripts and develop your own kind of tools within our tools. The Tungsten dashboard also has the ability to shun, or sometimes called fence, data sources. And what that is, it's really just to take a data source, maybe one of the MySQL replicas, temporarily out of the cluster because maybe we want to perform some maintenance on that node. And so we shun it, we do our maintenance, and then we unshun it or recover it and put it back into the cluster. And we would do this incrementally for each database node, for instance, if we want to apply a patch system-wide. We can promote replicas to primary. So we can make, suppose our primary needs to go down for some sort of maintenance. No problem. We just take a replica, promote it to primary, and now take that old primary, shun it, do the maintenance we need, and recover it back into the cluster. And that's included with our Tungsten clustering. So let's look at best practices when we want to deploy multiple active primary clusters in a geo-distributed fashion. So these best practices are really to help reduce the chance of having a replication conflict. The first thing that we're going to do is have row-based replication, and that's actually a requirement for multiple active primary databases. And I'll talk about that why in a second. But let's look at the next point, global unique keys on all tables. So when we do an insert, if we're going to use, for instance, auto increments, we would like each site to have its own unique set of auto increment values. So for instance, at site 1, if we have 2 sites, we might have, say, odd values for auto increments, and on site 2, even values. So that means on site 2, we'll never have an insert and with an auto increment value, say, of 7, right? It's only going to be even numbers for site 2. So this avoids insert conflicts. Now, we don't have to do it that way. We can also use a UUID or universal UID, and that would just guarantee that globally for our entire cluster, we generate a unique key. Whichever approach, it really doesn't matter. The only thing that we want to do is guarantee that we're going to have a unique ID when we insert records. The next point really is to shard users to the sites closest to them. And we'd want to do that anyway for the best user performance. But another side benefit that has is users are working on their own information, their own data sets, and so there's less chance of an update conflict. And now if we look at row-based replication, well, we want to do that because we don't want a remote site to generate its own key on replication, right? Row-based replication includes the primary key values on replication. And then a couple other points too is we want to synchronize the clocks on all the servers and use UTC time. And that's just kind of a given when we're deploying in a geo-distributed fashion. And also, it's desirable to limit the use of triggers. When we're doing row-based replication, we have to keep in mind that if we have a trigger that gets triggered on the primary, it's going to be written to the binary log. And therefore, all the replicas downstream should not fire that trigger. So that could get a little messy, and it's just easier to not use triggers in this sense. And just have your business logic handle those trigger issues. So let's look at some benefits, namely failover and disaster recovery. And this is where the process really shines because it's so simple to do failover. So let's look at, say, automatic failover. We have a user, and this user is connected to the cluster closest to him. And let's say that something happens to that cluster. All of the database nodes go down. So how are we going to handle this failover? Well, it's actually incredibly easy because remember, we have the tungsten connector, which is the intelligent proxy, and that's going to help us out here. The connectors will detect that there's no connectivity to the local cluster anymore. The database nodes have gone away. So the connectors will just automatically reroute traffic to a working cluster. And there's really no impact to the end user at all. There's no error messages reported on the app server because the tungsten connector, again, an intelligent proxy, handles all of that for us. So we've just seamlessly failed over to another site while keeping the user online. And fail back in this case is actually really easy. We bring the nodes back up on the site closest to the user. And then we just tell the connectors that that site is ready to be used again, and the connectors can repoint back to that site. So really easy failover, and just as importantly, fail back. But let's look at another scenario too, and this is a manual failover. And when this happens, this is because maybe an entire site goes offline, not just the database servers, but all the app servers with it. So now we need to kind of think about, well, is this really a failover situation? And if so, we can activate our internal failover rules, right? We just simply need to reroute uh, those users to another working cluster. There are a couple ways of doing that. We can use DNS, just have it point to another cluster. Or maybe we have some load balancer that's doing all the routing for us, and we just tell the load balancer to route to another working cluster. What makes this so easy is that since each cluster is active, there's nothing we need to do within the cluster. It's really a matter of just pointing the users to another cluster that's functional while we repair the broken cluster in the background. And again, once we repair that broken cluster, replication syncs up from the other sites, and then we can repoint the user back to that cluster and get everything back to normal. So let's have a look at the key benefits of tungsten clustering. First and foremost, tungsten clustering provides continuous MySQL operations, high performance, high availability with off-the-shelf MySQL. So you can use any MySQL version or installation that you'd like, Percona Server, MariaDB, whichever version. And it's a bolt-on application. We don't require any changes to the MySQL installation or any changes to the database itself. Tungsten clustering provides immediate failover within a local cluster, and it's transparent to your applications and users. So no one even knows what's going on in the background. Uh, with this and the ability to be able to re-provision a replica, um, it's really easy to recover from any sort of failover, whether database or server. And also we provide the dashboard, which we saw in this webinar. Some of the other things though too is zero downtime MySQL, right? So not only do we do automatic failover, but let's suppose you're doing maintenance. It's really easy with tungsten clustering to do maintenance on each database nodes without any downtime or impact to the end user. So that's also really important if we want to upgrade a server or maybe apply a patch system-wide. We can do it on all the replicas and then finally promote one of those replicas to primary and then perform the maintenance on the previous primary. And then what we focused on in this webinar is MySQL at a geo scale. So we can geo-distribute MySQL databases and clusters across the nation or across the globe, and specifically have your cluster closer to your end users for the best user experience. And we can add, subtract, or move clusters as we need to. And also, I did another webinar about this very topic, but hybrid cloud and multi-cloud MySQL. Use the cloud provider for each site that works best for you. You could deploy one site, say in Amazon, and another site in Google Cloud, and maybe even a third site on-prem. It's really your choice. You can mix and match, and you can load balance between all the different sites. But again, we offer you choice to deploy where you want to, and you're not locked into a particular cloud provider. So we touched on the tungsten connector. That's the intelligent MySQL uh, proxy. That provides all the intelligent routing that we saw in this webinar. And there's a whole lot more that the tungsten connector can do. It does really sophisticated read-write splitting and load balancing in the local cluster. And we saw how it can fail over from one cluster to another when that one cluster has an issue or goes down. And the best thing about this is that it's all transparent to the end user. A failover does not impact the end user because the tungsten proxy is proxying all of the SQL and all of the queries between the cluster and the end user. Tungsten cluster is powered by the tungsten replicator. And we really just touched on the basic functions of the tungsten replicator. It's asynchronous replication that can replicate within a local cluster or over a WAN. It works equally well on both, but it does a whole lot more as well. We can replicate from MySQL to other other technologies such as Redshift, Cassandra, Hadoop, Kafka, and Vertica. And of course, the tungsten cluster deploys on any MySQL server. It's not simply MySQL compatible. It actually uses MySQL, whichever version of MySQL that you like. Use off-the-shelf MySQL without a problem. Uh, One thing too that's really important these days is SSL encryption, and we do support SSL between all of our endpoints, whether it's replication, management traffic, or application through the connector to the database. You can encrypt that, and we support SSL for all of that. Um, and so when you add up all of the potential cost savings and the fact that you don't have to do any DIY or build it yourself, it's a really compelling solution. DBAs don't have to spend so much time on maintaining scripts and replication strategies and orchestration. Uh, you eliminate downtime, right? Because you're able to fail over within a cluster or even fail over to a remote site. And that promotes business continuity, which in the long run is also cost savings. And then one thing too that we are particularly proud of is our customer service and support. All of our support engineers have a minimum of 15 years of MySQL DBA experience. We also have experience deploying MySQL on Linux as well as cloud and sysadmin and DevOps. We offer 24/7 support with a minimum 1 hour SLA for urgent cases. But typically, we're able to respond in less than 5 minutes to get our customers back up and running again. Uh, our biggest customers have billions of transactions that flow through our tungsten clusters, and we're quite proud of that. Uh, we'd love to discuss uh, this or anything else with you. So feel free to reach out to us. You can reach out to anyone here. My name is Matthew Lang, or send an email to sales@continuant.com if you'd like. Definitely visit our website, continuant.com, and register there as well. Thanks a lot, and be on the lookout for our next webinar. Thank you.